Hello, in this video I gonna talking about this dashboard, what is going on here and how do I create the front end and back end. We're gonna talking about the overall system first. This system is illustrate how the IoT system in factory work, just like in the Thailand, my country that I live in. Okay, let's see what is going on my Docker container here. In my container we got a Mosquitto setup, which is MQTT broker here, and Fast API, which is gonna use for the API for my dashboard, and MongoDB here used for the database, main database for this system. Usually in the factory they gonna send the MQTT from the component, just like the thermometer or humidity detector or alarms, which is gonna send it to the database, right? Usually they gonna send the MQTT protocol because it's very fast and it's very light when compared to the other protocol. Once my server got the MQTT protocol from the component that I said, it's gonna be sent to MQTT broker named Mosquitto setup container here. Once this broker receives the data from the I2 system, it's gonna convert into the WebSocket and broadcast to anyone else within this server. Not only the WebSocket protocol is gonna broadcast MQTT protocol into the order. I have the addition code here, which is receive data from MQTT broker and store the data into the MongoDB. As you can see the code here, and this code is gonna contain three data: pulse wave, sine wave, and full wave here. Once the data has been stored in the database, we're gonna use the API in order to take data out and send them into the dashboard for the database security, just like you see in the general API server here. Okay, as you can see, my graph here is gonna show three data, and these three data is come from the API, and API is take the data from MongoDB. Okay, we're gonna run this graph, and we got a addition code here, which is this code is gonna send the data into the MQTT broker, and everything is gonna go as I say earlier. Okay, let's run this code then. Now, as you can see, when we run this code in order to send MQTT protocol to the MQTT broker to make this dashboard be able to run, this graph is gonna show the real-time data. Okay, we have nothing to say about this graph because that was too basic for the real-time IoT system. And as you can see here, we got a water gauge here. It's gonna correspond by the water level, and I'm gonna show my code that write about the water gauge. Let's see which one. Okay, as you can see here, I write the code and we can change the name of this water gauge here. Let me correct it. It was so random for here. Okay, I fixed it already. And as you can see, we can change the host here, change the port and WebSocket part, because this gonna take data from the because this water gauge is gonna take data from WebSocket server, aka is a Mosquitto setup, as you can see here and I said earlier. And I send the random data between 0 to 200. If you want to change the max gauge here, we can change the data from the static number here. Okay, as you can see, when we turn the number into the 300, the maximum number has been increased into 300, and everything is working properly, correspond to the data is sent, and the maximum data here. Okay, we have nothing to do with this page. Oh, the other thing that I almost forgot to say, I can change the theme here, which is looks really cool, right? Okay, next one, we're gonna look at this page. Oh, I kinda like the dark theme instead of light. In this page, we can show the data from the past, and yeah, it comes from the API server. Just like when we want to look at the data at the 19th October last month, at 9:30 p.m. Data that we find here is gonna show at the middle of this graph. We can change the time here, change a minute, and be able to change the interval here, because this one data is shown for 1 minute, right? If we want the additional data, just like the 5-minute graph, we can change the graph here. My API is gonna calculate the whole data that taking from the database and summation of this together and find the average value of the 5 minute, which is come from the 1 minute 5 data. Okay, this graph be able to change to 4 hours, which is the summation of the 1 minute data. It's gonna take a while because it's gonna summation many graph, because every data has been stored in the minute. So that's why no wonder why it looks very lag here. Okay, next one is current status here, which is shown the real-time data from the factory component that I just said earlier. You can see the status here, which one is online, which one is offline, temperature, humidity, RPM, power, and the other stuff is the alarm box here. My simulate data from the IoT is gonna send data into this alarm box 4 seconds one data. As you can see here, we can see the time here, and I fixed the static time with some malfunction. Oh no, the time is right because this time has been set. The minimum data is the minute, so now is 7 p.m. 21 and 32. That's why no wonder the data is seems stuck, but actually it's not stuck, so rest assured. Next one, we can see the originator is gonna show the alarm is come from which silo is that, and we can see the type here, which is I don't set the variable of data, so that's why you be able to see the overload on every possible data here. And as you can see, we can see the severity here. Is that a critical fault or just the error or common fault that you'll be able to see in the factories? And the whole system here is real-time data, except this one, because this one is just data recall. So why do we need this graph to be real-time, right? Okay, that was everything about my dashboard here. Thank you very much for seeing my video. Thank you very much, everybody.